Oh, I still see the same people here. Charlotte, who is in studio. There's a lot of space in the LT with PowerPoints. You can come over. Okay. So we will pick up where we left off. But before we pick up where we left off, I will just have a quick run through. Okay, so essentially what the main point about this whole exercise to teach you all Python is to let you know that it is a way in which you can customize and create two things. One is to automate repetitive things. The second thing is to generate different kinds of design. Okay, so you will be able to set up an algorithm. An algorithm is just a fancy way of saying you have a specific set of steps to reach a goal. So this algorithm can do something that's repetitive, or it can also generate something that you may not have been able to conceive in the beginning. And that's why we are trying to use this custom user object exercise so that all two categories of students, which I mentioned before, right? There's a category who is very comfortable with learning this kind of spatial computational techniques. And then there are the others who will take some time to get used to it, but they may or may not want to use this technique in future. Okay, but at least they know that there is this particular technique and workflow in which they can automate their designs. Okay, that's why we have this custom user object, which is very achievable for both categories of students, right? Because essentially it's still just Grasshopper, clustering it together, and then packaging it to even like a custom icon. And that's why we will move on to the Python portion over here. Okay, so just a quick recap. For Python, we always are able to call upon libraries, and we can abbreviate the library. So in this case, the bulk of the lesson today will be using a lot of rs dot and then a function or a method. So this is where you will call upon a particular function or method from a library. This is called a library. This is the abbreviation for the library. Okay. And what we have done last week was to be able to get all of these points, okay, from the surface itself, which is what we have done using Rhino Grasshopper with the deconstruct brep command. Okay, and we are able to display this now as an output in the Rhino viewport because we have created a list called A, and the abbreviation is to use square brackets to create a list. So again, a recap, what we have done is we use this Rhino script library, and then we call upon this method called evaluate surface. So all of this line creates a point, and we are appending each of the point into the list. So say, for example, graphically, I'm just going to sketch so that you all can recap and understand the concept. I'm just going to arbitrarily say this is U and this is V. Okay, so essentially, whenever we are talking about this, I divided by num U and J divided by num U V, what is happening is that we are already telling Grasshopper it's from 0 to 1 in terms of U. This is 0 to 1 in terms of V, because we have reparameterized it. So it's always going to be from 0 to 1. It's similar to the divide curve command that we have done before, where a curve is determined from, like any curve, if you draw, it has a start point and an end point. Anything else in between are just like, if this part is called 0, and then if I'm dividing it to 1, 2, 3, 4, then this one will be 0 0.25, 0 0.5, and 0 0.75. So the logic behind this over here, where we have I divided by num_u, is where we are going to create all the values from 0 to 1. For example, 1 divided by a number 1, so that will be at 1. And then 1 divided by a number 2, that will be 0.5, so on and so forth. So that's how you get all of these points step by step. So it will first start in the num_u range. So what will happen is it will keep looping here, right? That's the first so-called column that it will generate. And then after that, the second column, because it will start to loop it in the V range. Okay. So that's how we will understand it as humans, right? You do here first, and then you do here. But for computers, they can compute it in a significant fraction of that time. Once they understand that you have this nested for loop, they will generate this entire array of commands, which is the evaluate surface. Okay. Now, what we are going to move on for today, right, is, and which is also why I'm trying to explain to you in such a manner, is that the outputs of this particular workflow will give you a linear list. Okay, so I will again try to use this analogy. Imagine if I'm dividing from 0 to 10. As in I have 10 points here. So I will be counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, right at the end, this is 9. Then the next one will be 10, 11, and 12, and 13. Okay, so it will go in this manner, right? Okay, but that is not useful for us, because what we are trying to achieve now is something similar to this, right? Technically, mathematically, we can still control what we want to have our end result. Let me again use another color to get these squares, right? You can still skip and manage the points, but an easier way to arrange this information, instead of having it as a continuous list like this, right, is to make it into a dictionary. So what I'm going to just sketch is okay, I will write here. Dictionary allows you to create a database and identity of the location of your information. Whereas if I were to use the list, is a linear arrangement, 0 to infinity. Okay, so it could be from 0 all the way to 1 million points. But in order to extract information here, it's harder than if it's as a dictionary. So do you all now understand what is the difference between list and dictionary? Okay, so list is always counting from 0 all the way to the end. If I have 100 points, they will all be labeled from 0 to 100. And if we were to use dictionary, what will happen is that there will be an index. So an index meaning that we can count it to become either U and V. So that means I can generate an index. For example, this particular point here will therefore be in V, it will be 0. Or if we were to count in U, it's always U first, okay, U is 0, and then V will be 10. If this is a 10 by 10 grid. Kind of like a graph. You all understand graph in secondary school, right? Okay. And then this will be much more useful because if I were to translate this concept to this dictionary concept over here, so now this is what we are going to do. This is a programming convention. Okay, when we try to count in Python, we don't use the U and the V directly, right? We will use a placeholder called I and J. Otherwise, you will keep getting confused about the two different variables. So what is going to happen is, say, for example, again, like if it's from a 0 to 10, and then 0 to 10 over here, this will start off as being 0, 0. Maybe again, I will do this snipping tool. So it will start off by being, this one will be 0, 0. This will be 1, 0. This one will be 1, 1. And this one will be 0, 1. All can understand, right? As a graph. Okay. So in this way, we can always be able to extract. That's why I've drawn this in light blue. The next point for this particular grid instead shall be 2, 0. And then this one will be 2, 1. And you'll still use this number for this second grid. Okay. And we will be able to let the computer use the for loop to loop between all of this to create all of these squares. Right. So now you will know why this is a significantly better method than if we were to use the list. Right. The list will just go all the way up and then come down here again and start this new column again. Okay. All clear on this concept before we even do the scripting portion? It's important to understand before we even type things. Otherwise, you are just like doing a testing exercise, a typing exercise today. Like looking at the screen and trying to match my typing speed. Okay. I take it everyone understand, because I don't see anybody looking very confused yet. Okay, so I will continue. To make sure that you all can catch and also don't test all of your eyesight, as I've highlighted before, the files are already here. This is already published, right? Download them. And then what I will recommend for you is to use WordPad. Okay. If you're on Windows, for Mac, I don't know. So you find your alternative text document. Don't use Notepad, because WordPad will still allow you to have the coloring of the script. So what you should do is you open those reference files that has already been uploaded onto Canvas. And then you just simply like double click on the Python script, which is what is happening here. Then you just copy, Ctrl+C, and paste inside here. Okay, once you paste this inside here, you will be able to see it as on the screen, on your own screen. Then you don't have to keep squinting over here. And that also is good for those who are attending online. Okay, and even before we start typing, I'll just tell you what is the difference between where we left off. Okay, I'm just going to put here side by side. This is where we left off last week. This is the file that I saved, which all of you should have a similar file. And this is what we are going to type in the next few minutes. Okay, the difference is here. Okay, maybe let me just do a screenshot again. Okay, I guess I will just save this so it's easier. Okay, and then I'll just do it. So the difference between these two, in terms of the syntax, right? Let me just highlight. Is here versus here. And then here versus here. Okay. So square brackets, this is the list way. And then this is the dictionary way. Okay. Just remember, when you want to create a list or a dictionary, you have to tell Python that you are creating this list or dictionary. What I'm doing now with these two lines here, A equals to square bracket means that I'm creating a list called A. Okay. And then for dictionary, what we are doing is we are still calling it A, right? But we'll call it A equals to curly braces. So curly braces will let Python know that, okay, you are not going to, I'm not asking for you a list. A is going to be a dictionary. Okay. And then the way in which you generate and manage these two different kinds of information, the first one is append point. Okay, so this one is where you will put all these points. So all these two lines here are exactly the same. They're just looping everything and creating points. But after every point is created, this one will be added to the list step by step. Again, from 0, 1, 2, all the way until 100. Similarly for this over here, what will happen is it will take all of the points right? But we are assigning this grid, the I and the J grid, which was as per the which were as per to this example, right? So I'm already concurrently, as I'm looping, that's why just now I was explaining what the for loop is doing. I'm creating an identity of all these points, 0, 0, 0, 1. Every time I create this identity in the dictionary, 0, 0, I'm also assigning a point to it. Okay, so that's what the dictionary does. All clear? Can, right? Okay, so we can just simply go to Rhino. So this is my file. So all go to your own files. Oh, it's the same thing. I have to mute someone again. Yeah. But all are muted already. Okay. I guess the guy realized it himself. Okay. Never mind, we continue. So yeah, it's here. Okay. So what we just need to change over here, right? This thing just change to curly braces. Okay. It's directly above the keyboard for the square brackets. And then what we're going to do here is we're going to do the A and then this bracket, comma, I, J, this equals to point. Because we are assigning this point inside here. Equals always mean assigning. Okay, so just make sure that you have seen this. So as recommended, always have this copy and paste. I will also leave this here so I can minimize. So that even as I'm typing the general window viewport, you all can see the code that we need. Once this is done, just type test. Okay, so nothing here means no syntax error. Okay, tests will only help you to check whether there's any syntax errors. It doesn't mean that it will check your code for you. Because sometimes the syntax is okay, but the logic is wrong. You will still have a non-red color Python, but it will not turn red. As in, you may still have some logic incorrect. What you will notice now, right, is that after I've done this, everything is fine, but you don't see anything displaying on the Rhino viewport. Okay, why is that? So this is similar to what we have learned in the deconstruct VREP. Deconstruct VREP essentially creates a list of points, right? That's how we use the list item to identify each of them. But for this, what we are creating now, A as the output, is a dictionary. Even though there are points, but to Grasshopper, it just understands it as a dictionary. So it's not outputting it directly. To Grasshopper, a list are still points, you know, but dictionary is a more of an information structure to Grasshopper, and that's why it's not displaying it onto the Rhino viewport. But that's fine, okay? Because now what we are going to do, so you should open up the next file, which I also have it open here, which is this quad example here. So you should go to your canvas and open up this quad file. So double click, and you can just take from here, Control C, and go to your WordPad and paste. You see, when I paste in WordPad, it will give this color coding as per the original syntax. Okay, now let's again compare what is different between what we have typed earlier on, which is this one. Okay, so this one we should just update it to create a dictionary of A, right? And what is going to happen is same thing. I was just telling you, Grasshopper will preview list, right? So other than having a dictionary, we are going to create a list, and it's going to be called pattern. Okay, because we are going to create two patterns now. We are going to try to create one that is a quadrangle, and then the second one that is going to be a triangle. Okay, and we are going to be able to use conditions to choose between which kind of thing we want to make, whether we want to make a quadrangle or make a triangle. And that's quite similar to the example that we did earlier on, like maybe the second or the third lesson, where we use a value list to choose which one we wanted. Okay, so let me again have them side by side. So I'm going to create a list. So a list is, of course, brackets. So pattern equals to bracket. So essentially, again, to be very naggy, that means I'm creating a list called pattern. Okay. So after this, you can see the indentation is aligned like this. Okay. So what this has done, this is just giving a dictionary of points called A. Now what we want to do is we want to be able to create a line. Okay. So I'm just going to delete this first because this is what we're going to do later. We're going to create a line using a polyline command in Rhino script, and that's called the dot add polyline. And what it needs are points in which you are creating that polyline. Okay, so I'm going to ask it to go in this direction. Okay, so let me just use the arrow tool. So I'm going to go in this direction. and finally come over to here. Okay, so it's the exact same thing that we were doing just now for here. Okay, so if I were to put them side by side, so we are creating a line, a quad, by drawing a line from here 0 0 to 1 0 to 1 1 to 0 1, and then back again to 0 0 to close it. Okay, and then after that, we are appending this drawn line as a list called pattern. Okay, all clear? So you understand the logic, huh? You all must understand the logic before we even type it out. Okay. So I can always create a comment again. So now I'm just going to say that I am drawing a quad, right? And the cool thing about Python, at least to me lah, because I'm a very lazy person, if you have not noticed before, I will just copy and paste my scripts that I have done before, and then I will just tweak them. So what is important here, right, is we don't have the +1 anymore. Okay, why is that so? You remember last week, what happened is that they did not give us the points at the edges. Okay, because if U and V was here, all these points were missing. So that's why we had to have the +1 to identify these points. If now I add +1 over here, it's going to draw a line further away from this. Okay, because we have already created the dictionary properly. So now I don't need to loop for it with a +1 anymore. You can test it out by yourself later, but I will not confuse those who are already struggling to do that. But I'm just highlighting to you what is the rationale first. Okay. So I copy and pasted the first one, and then I will just type in this for J loop also. You can also copy and paste from your earlier line over here. Because essentially this is doing the same thing as this, just that we don't add the +1. Now the next thing is, as you can see from here, we want to create a temporary variable called quad equals to rs dot add polyline. Right, that was the logic that I was explaining to all of you. So once you call rs dot, means I'm looking to this library called Rhino script, right? I abbreviated it earlier on, you see, Rhino script syntax as rs. So rs dot add polyline. Once you put this normal bracket out, there will be a help over here, and it's just asking you to input all the points. So if you understood this concept earlier on, you will simply just type in as per the logic that I've just mentioned. See, so this is all your dictionary elements. These two things are the dictionary elements, and you are simply incrementing them in the I and the J direction. Okay. So by right, if you truly understand, you can just type this. So what we will always start off with is we will start a square brackets. So this will tell Python that there is a whole list of points. Okay, I'm just going to do pseudo code here, okay? This is the method rs.polyline, right? You have to start and the stop with this bracket. In between this, you should have a list of points, which is controlled by here. Otherwise, it will be confused here where it will ask you whether you want to replace or not replace. So all your points will be here, 0.1, 0.2, 0.3, 0.4, and finally 0.1 again, right? Because we are drawing a rectangle, right? So you'll be here 0.1, 0.2, 0.3, 0.4, 0.1 again. Okay. And then, now that you understand this logic, you can put in the individual points. So again, I can be lazy. I can just go here and I copy and paste this over here. Right, this is my 0.1. Then what is my 0.2? 0.2 is this one, right? I plus 1j. So here, I plus 1. So this 0.2. And then my 0.3 will be the one going up, right? So it will be this one, I plus 1, j plus 1. I plus 1, j plus 1. Then 0.4 is this guy over here. Okay. Maybe just to be easier for all of you, I'll just type this in. This one will be 0.3. Okay, understand, right? 0.1, 2, 3, 4. This is the direction. And then we are typing it here. So 0.4 will be this one, I and then j plus 1. Okay, and then finally, the last point, which is back to square one. Okay, and it doesn't stop there, right? Because after you have done this, you are just creating a variable called quad. In order to show it out, you need to append it to a list, which we have just called pattern, right? So same thing, the syntax is pattern.append all of these quads. Okay, now you test. Test no problem here, which means everything is good. Then you click OK. But you also still don't see anything. Why? Because here, in your Python syntax here, there is no output called pattern, right? It's only called A. So what you need to do is just zoom in here to this plus sign. Just right click and call this pattern. Click on the outside. And just to refresh to Python, right? Okay, I have this new output test. Okay, and then now you will create all of your nice little quads. Okay, I'm going to pause now again and try to look at your body language. Any confused souls or those suffering in silence? Oh, today the cross flag guy never come. Okay. Yes. Or shift this away. Okay. But this is actually what is in the reference. This is the one that I've just typed in. I can open this whole thing up here. It will still be missing some because the font size, with this font size, right, it cannot squeeze in the whole list. So you have to check from the reference file that I've sent. But more importantly, right, is to understand this logic. Yes, you need to close, otherwise you will get a C. It's not a rectangle. It's an inverted C. Okay. What I'm going to do now, right, is I will quickly do the triangle command, which is just copy and pasting this and removing certain things. And then we will break for the your breaks so that you can get your coffee, and we will start to do the conditions. Because now, as long as you are comfortable with this whole logic, it'll be very easy for you to grasp the other things. So now what I'm going to do is we're going to draw a triangle, right? So the logical way to do the triangle now, what will happen? You see, I just drew this thing, this arrow here. I'm going to delete this now. Okay. So when I want to draw a triangle, I simply make it 0.1, 0.2, 0.3, and back to 0.1 again. Understand the logic? Okay. So what you should do here, we are also going to create a triangle. Okay, so I can, it doesn't matter, I can just leave my quad over here. And I'm going to be lazy, okay? I'm just going to take this whole script that works already. I will copy, and then I will paste here. Okay, but now I'm going to call this tri, T-R-I, short form for triangle. And the thing that I just need to remove, right, is my 0.4. 0.4 is no longer in my example, which is this one. So I deleted. Make sure that there's no additional comma over here also. And then I just need to tell Grasshopper, instead of appending quad, I will append my triangle. Okay, that's okay. And then you will see now, you draw the triangle. Okay. You look very shocked. Yes. Show the last thing. Okay, I don't really want to show the last thing because then you are not really understanding it. Okay, you see, the whole thing is, you must think of it side by side. Okay, what we have already done, if you have done the rectangle, is to have this point 1, point 2, point 3, point 4, and then back to point 1. The next line here is we are just going to call this triangle, tri equals to rs. Same thing, you just copy and paste these two lines, and you remove this point 4 here from here, so that you draw the triangle like that. Okay. So you will realize, right, actually doing this Python, you can either be horribly lost, or if you just take the time to understand, you'll realize that most of the times it's quite logical. As long as you understand the dictionary concept, you can manipulate all the points to do whatever you want to do. Like now we are drawing rectangle and triangle. Okay. Once you master this, you can also do the future of us that I showed you before. But essentially, it's still just triangle. It's just a different way of drawing a triangle. Or you can also draw a circle. Up to you. You just get the center point here and draw a circle. You can draw anything that you want. Okay. So now it's 9:52. We will come back at 10:07. 15-minute break. Those who are confused can ask your TAs to go around. Those who are confused but yet want to suffer in silence can go and buy your coffee and come back and try to understand yourself again. And then ask your TA in the tutorial session. Okay.
The part where you with the try and the spots, I think some people they need to catch the.
Yeah.
Maybe we can make it bigger.
But if I make it bigger,
oh.
I have to make the font smaller. But if I make the font smaller, they also cannot read. That's why I was telling them the logic is that they should just open up the reference file, then they can see it from the reference file. See now? I don't know whether you all can see it.
I think it's okay for now during the break so that they can just make sure that they scan this part accurate.
Oh, okay. The only difference is this.
But if you already bring you said that the starting point of it yes. Yes, there's a yes. For your information, it is we tried, it doesn't work.
I was just counting the number of people in the lab, around 50. So plus the online ones, which should be in the computer lab, there's only 90. Oh, 175. There is a 60% attendance. I think the TAs already made it clear, right? By right, you all have to come, especially for the tutorials, because they will mark for the attendance. So if you are coming for the tutorial, you might as well come for the lecture, right? Okay. Anyways, yes. Once you sit down, we will start. Okay, so we can resume from where we ended. Just go to the canvas and open up this file now, which is the condition. Okay, condition.gh. Okay, the rest of this will be quite fast because it's just using the same logic as per the Esplanade tutorial. Okay, but for now, we will just use the condition first. So just as a refresher, right? Last time we showed you how to use a value list, correct? Very, very early on, just to give you all confidence. So I'm going to use a value list. And for that, I need to have an input. I will zoom in here and add an input and call this PATT. Okay, and my type hint shall be an integer. Okay, because I want it to be a number. And then this one we have gone through before, right? So we will double click and type value list. And what the value list does is, if I right click and edit, I can input, for example, my quad equals to 1 and my triangle equals to 2. Similar to here, this logic. Okay. If this particular number, this pad, equals to 1, then I will assign a quad. If I want a triangle, which I will change from this value list, because triangle equals to 2, right? So if pad equals to 2, then I will get a triangle in my list. Okay, so once this is done, just click OK, and then you will see that this will be quad versus triangle. Just plug this inside over here. And now just need to edit this code. So what we will need to do now, here, I'll just do a comment so that you all can understand. So creating a condition from the value list. Right. So I'm just going to minimize this so that you all can all see it side by side. Okay, so it's this part here. So the logic is if, and then open bracket, PATT equals. So a refresher of what we did in the value list tutorial. Equals means you are checking. One equal sign means you are assigning. Okay, so I'm just checking whether my pattern equals to 1. So always remember to add these 2 little dots, enter. Then I will do this part, which is this equals to pattern.append try. Equals to append quadrant. Okay, and then again, see, I'm going to be lazy. I just copy this whole thing, Control C, Control V. If it's 2, then I will append my try. Because you see, what is happening here in the background, Python is doing both the quads and the triangle in the background, right? Using the dictionary. But what we want to show is whatever that is assigned to pattern as a list, because only a list is shown in the Rhino viewport. So I just test. No problem. Click OK. And you'll be able to see now that as I change this, it will choose what I want. Okay, I can toggle between these two. So technically, with your coffee or your food from the canteen, you should be able to grasp this quite quickly. It's exactly what you all have learned before. It's just that now we are appending it as a list. If you cannot remember, it's here. This example, lesson 2, tutorial 01, box more value list. Okay. All can. All value list can work. Then go to this file and do the same thing. Okay, so open up this, and you'll see there's a lot more things declared now. You're going to copy and put it here. So you'll notice in this next step that we're going to do, which is why I asked you all to go for the break, a lot more input outputs here. And then I'll go here. Okay, this is what we have as of now. Okay. So let's just compare, okay? What we have done earlier was only just to have the dictionary and the pattern, right? But now what we want to be able to do is we want to be able to, if I were to go back to my diagram over here, last time when you all did it in Grasshopper, you understood the logic, right? What we did earlier was to create a line between this point and this point and take the midpoint. With the midpoint, you measure the normal here, which is the perpendicular direction. That's what they call it in 3D, a normal. And then with that direction, you'll move a point on top, and then we just draw the triangle around it. That was what we did for Grasshopper. So it's the same concept that we're going to do. We're going to create a list of normals that goes all the way up. We will also create, with that, we will create a list of points that is on top, which we will call it point up. These are all case sensitive, so make sure that you will write POINT, lowercase, then U, uppercase, then P, lowercase. Okay, but in order for us to get this normals, I will also need to do my vectors. in this direction and this direction. Then I can do the cross product. It's the mathematical thing that we have done before in the Esplanade tutorial. Okay, so step by step, we will go to our Grasshopper here, right? And we need to declare more list. So same thing, norm equals to a list. Point up equals to another list. And then vector with a V capital equals to another list. Vector 2 equals to another list. See, this one happens to everyone. See, make sure that you check. Don't have typo. Sometimes your fingers are fat, then you will type wrongly. Okay. Now, if you were to look over here, this is the difference that we have. Okay. So essentially, just now we were drawing quads and triangles. But now, what we want to do is we want to draw a guideline. Yeah. Okay, I will maximize this. Yeah, I will change the font size. Whoa. Okay. So this one is more legible, okay, because it's line by line. Let me just focus and explain first before we type. Okay. Originally, we were doing a quad and a triangle earlier on, right? Now we are going to move on. We are going to create this guideline. And it's going to be right here. It's from here. I'm just going to put this side by side. Yes. Yes. Okay. So imagine this is the I and the J here. And then this is the I and the J here. Okay, this is in 2D and this is in 3D so that you all can understand. What we are going to do now is we are going to draw from here to here as the guideline. Right? This is the guideline. From here to here. And then, exactly as per the Esplanade tutorial, we will find the midpoint by using the evaluate curve. And then we are going to evaluate the start and the end point, which is using the curve, which is this curve, the start is always 0 and the end is always 1. The mid is, of course, 0.5. So that is the logic. So you create this new line here, and then you're going to get the 0.5, the start, and then the end. So now I'm just going to, we don't need to talk about 0.1, 0.2, 0.3, 0.4 already, right? So what we will have is, this is 0.0. This is 0.5. And then this is 1.0. Okay, this is precisely what this is doing. Okay, so what we will do here, this part, up to you, you can leave it there. I'm just going to hashtag it, okay? So that it, once you hashtag it, it will not run. It's just a comment. Okay. And what I'm going to do now is, I will still keep it within this loop. And like what we mentioned, right? I'm going to create a new comment. I'm just going to say draw guideline. Okay. And my guideline equals to rs dot add polyline, which is the same line here, right? And then I'm going to put in my points. So same thing, going to be lazy. I'll just copy this thing here. And then I comma. And then I will just put this to be +1 and +1. Again, why? Because, let me just open this thing here again. So it's from here, this guy, here, to this guy. Okay. Then I'll close my bracket, because these two brackets are commensurate with each other. And then the normal bracket. So square bracket, and then normal bracket. So test, see whether there's any syntax error. No errors, that's good. So what's the next thing that we're going to do is you see from here, we will do our midpoint and start point and end point. Okay, and all in lower caps. So what I'm going to do here is midpoint equals to rs. And then now we're going to use a new command called evaluate curve. It's the same command in Grasshopper, the point on curve. Okay. So you will need to have an input of what curve it is. So this is my curve, comma, and then you need to tell it where I want to evaluate it at. So 0.5 will be at the halfway point. So similarly, I can be lazy, Control C, Control V. So I will have my start point, which is 0.0. And then I will have my end point, which will be 1.0. Yes. And that's fine. Okay, so if I were to go back to this part again, what has happened is we have this point, this point, this point. Okay, and the next steps that we are going to do is we are going to create our vectors. Okay, you will see here, this one is it's like what? It's the Easter egg, you know. When we have the vectors, they are on opposite sides. If it goes here and goes here, you will not be able to get the perpendicular. It has to be not on 180 degree. So later on, for those that are alert, you will realize that in the next example file, this vector file, you will realize here, point to this one, not the endpoint, but to the ij plus 1, which will be this one. So what we will be doing is we are going to create a vector from here to here, and then from here to here. Okay, this is to catch those that are just blindly copy and pasting. Okay, from here to here, and from here to here. Yeah, let's put this side by side. So this was our file earlier, right? So double click. So after we have this, I will just comment, create my vectors. So my vector, my first vector, which is this one, I will have them arranged like this. So you can always still see here the diagram. Okay. Vector 1 equals to rs dot. We will use this command called vector create, which will need two things, right? The start point and the end point of your vector. So my start point is my midpoint. Okay. Let me call up my giant cursor again. Okay. So you can see my cursor now. I want to start from here. From here to go to here. Here to here. So it will be from my midpoint to my start point. Okay. After that, I want to append this to a list, which we have already created. Remember, we have created this list here. So vector 1 dot append, and it will append all of this placeholder variable here. Okay. And let's just be neat. I will just copy and paste this. And the only thing I need to change is to call this vector 2 instead. And now instead from midpoint to start point, it will be to ij plus 1, which is this one. Okay. So equals to A, okay, that's our dictionary point, remember? J plus 1. close bracket. Test. Okay, so now we have created two vectors. Vector 1. Maybe let me just again, I'll call this vector 1. Ah, stupid cursor thing. Okay, move it down back to the normal one, and this one is my vector 2. Okay, vector 1 going here, vector 2 going here. Wait, okay. So understand the logic here. This is here. This is here. So this is the midpoint, which is 0.5. Everyone clear, at least in terms of the logic now? It's exactly the same logic as when we were doing it for Grasshopper. When we were using the list item and then getting the vectors. So you'll realize that after that, there's two more steps. Okay. So what we need to do is we will need to create a cross product of this, right? Create cross product. Okay. So to create the cross product of this particular two directions, what we need to do is again have a placeholder variable called vector c, c meaning cross, right? Equals to rs dot, and when we will use this other Rhino script command, okay, called vector cross product, which is this one. Every time it auto completes for you, you just press enter. Okay, so I just need to assign it these two vectors, which is the 1 and the 2. The 1 and the 2. So by doing this, you are already getting the perpendicular direction. But the next step that we are going to do is we are also going to do two things in one. First thing is, you will realize that after I draw my surface, right, the vectors are pointing downwards. Sometimes when you did the sunshade tutorial in Grasshopper, the vectors were pointing downwards. And then I asked you to do a negative X, remember? Then you will flip the direction. So in terms of Python, you will just use this command called vector reverse. Okay? And then with vector reverse, you will be reversing the direction of the vector. And what I'm trying to illustrate to you over here, right, is that not only can you do the vector reverse, you can unitize the vector within the vector reverse. So this is called like a nested function. And that's one of the beauties of creating, as in learning Python. Okay, Python essentially is a object-oriented programming language. Okay. Now, whatever that we are doing, right, is just the beginner level, right? We were showing you how to use these methods and functions from the Rhino script library. And here I'm just doing a baby step of nesting another function within this function. Okay. When you become more advanced, you will write your own functions. Okay, that can be recursive. Means it will just keep repeating by itself until a condition ends. And after that, when you're even more comfortable after writing functions, you can write classes. Then classes will introduce you to object-oriented programming because all your objects can have their own class assigned to them. And that is where you will really extend the power of Python as a scripting language. Because you can do recursion, you can do evaluation automatically. Okay, this is a bit more high-tech, but I just want to tell you all that these are the slow progressions that you can move on to once you're comfortable with this. And then you can, once you understand the language, you don't necessarily have to do this Rhino 3D thing. We can even apply that language to data science, machine learning, AI. Okay, so back to reality now for your lesson. Vector U, right? So now I'm going to do a placeholder equals to rs dot vector reverse. Okay, so I'm just reversing whatever vectors that's going to be inside here. And the cool step is that we are also using the vector unitize command to this guy over here, which is my vector C, my cross product. So just remember that you have to close the bracket. This one is to close this guy. See the purple bracket thing? And this one is to close this guy. After you have done that, then you will just need to append it to a list, which we have already created just now, called vector U. And then finally, we will just move this point up. Remember last time, after you get the direction, you need to move your point up, right? So what we will just do is we will create another placeholder called point up. And then we will use this command called vector object. Move object. So it essentially just needs to know what you want to move and how you want to move it, which direction. So we are going to move our midpoints, right? This was our midpoint. And then we are going to move it in the vector U direction. And of course, finally, after you have done all this, you will append the individual point ups to a list called point up with a capital P. And then you will visualize this on your Rhino viewport. So I'm just going to test this first, but I will just leave this here for now. Oh, there's an error. Line 43, vector u is not defined. Okay, let's go up. So here I didn't define another list called vector u. Okay, so we have to define the list at the beginning. And just to be neat, I will create this. So all this is the dictionary. These are all my lists. Okay, it's vector u like that. Test. Point up. Oh, I typed this wrongly. So this one should be point up. Okay. So this is the placeholder, and then this is the list. So just now I typed this wrongly. This one should be capital. So after I tested this, there's no more errors. I click OK. And the only thing is, I'm not visualizing the point up, right? So I need to zoom in here, plus, and call this my point up. So same thing as before, just now in the morning. Yes. Okay. And now you will see all your points that are moved up. Just going to put this view, double click, and show you what's the difference. Okay, so make sure the lists are all assigned properly, created properly. And then after that, this is the part that we just typed in earlier. Okay. No. Why? What's wrong? Which part? The next few steps are just to draw the new triangle now. So now we already have all the corner points, and we have the up point, right? The next step is just to draw the triangle around the
Sorry,
corner
can you?
points and the up point.
Sorry.
Yes.
Can you scroll like up to the loop 4 points, like below loop 4 points? I think we missed like some of the parts from there.
Scroll to which point?
Below.
Move object.
Below line 22.
Below line 22.
Yeah.
This one is should have been there from the beginning. This is the fundamental thing to establish the dictionary.
Okay, thank you.
Okay, so now what you can do is I'll just copy and paste these two references for the panels. Okay, and explain to you what's going on. Okay. So this was our script. And we ended off here. So we have a point that is moved up. Now what we're gonna do is we're gonna draw the panels, right? And it's going to be starting from the start point to the point up, and then to the ij plus 1. Okay, so this part is the important part, which I'm going to sketch over. Okay. So I'm going to create a 3-dimensional panel left. I will use color to highlight to you. So this one will be this point, right? Which is this point. Then we have our point up, which is this one. Okay, our point up is here, which is somewhere here. Okay, after we have done the cross product. And then finally, we will have this orange point here, ij plus 1, which is this guy here, and also this guy here. So now do you all get it? So with this panel left, I'm drawing a line from here to here to here. This direction. Can understand the logic? Understanding the logic is more important than typing it out. Even if later you type got error, right? It's fine. The TAs will help you sort out the typing errors, like case sensitive or something like that. But the important thing is understanding the logic. Okay, so now what we just need to do is I will put them side by side with this sketch here. Okay. So what we are going to do is we're going to create our panel left, right? And our panel left, this is again a placeholder, okay? This guy here is just there for the moment. Equals to rs dot add polyline. So same thing as what we have been doing the whole morning, just drawing lines, right? So I draw a line and I want it to be from my start point, which is the A bracket, I and J, right? And then close this bracket. So this is the start point, okay? This is this guy. Then I will go to point up. which is what we already have here. Then I'm going to go down to this point here. This point, the orange point here. So I'm just going to be lazy. I will copy and paste this. And I know that this is j plus 1. Okay. And again, as usual, what we have shared with you earlier, right? Your triangle must come back. Okay. So come back to the start point, which is this one. And close this bracket, the square bracket, and then close the comma, close the function. Okay. You can see here, I'm deliberately putting the squares, the spacing here, so that you can understand. But next time, once you are more comfortable, you don't need to leave so many spacing. And after you have done that, then you simply use the same trick again, right? I want to append all of this into a list called panel L with a capital P, which I have to go up, remember, our list of list goes to this bracket. And since I'm here, I'm just also going to create another list called panel R. Okay, so in the beginning, you must always tell Python, okay, I want how many dictionary, how many lists. Then you will know to do this, to set it up. Okay. So the only thing that I need to change here now, right? Once you understand this logic, which is why that's the beauty of it, I can take this whole thing, I copy and then I paste. So again, to hard sell you, learning programming is good for lazy people because you invest this time to understand the logic, right? After you understand the logic, you can be very, very lazy. You can just repeat parts of the code that you have created before, and then you just fine tune. If you can recall, right, from all those examples that I did in SUTD, and then later I do for my own project, it's also the same thing. It's just tweaking a bit of the variables and the logic. Okay, so the only difference here now, diagrammatically, right, what we have drawn is, let me just maximize this. This purple line is my panel left. I want to create my panel pink, okay, panel right, which I can start off by having it here. I'm starting from here, and then I'm going up to my up point again, this one, down to this orange point, ij plus 1, which is this one, and then the back again. Okay, so you understand this logic already. So it's here at this corner, go up, then go back to this I and then j plus 1, and then go back to the same point again. So if I were to just go back to this panel right, I must change all these variables from L to R. And then this one will be this plus 1, j plus 1. Point up is still the same. And then it goes back to the same place. The ij plus 1 here, this corner. And finally, back to the same starting point again of your triangle, which is the plus 1 here. and nothing is wrong, click OK. But to visualize this, I just need to plus, and I will call this my panel L, and I will call this my panel R. Same thing, test, okay. And now you should be able to see all of your beautiful sunshade here. Okay. I can just create a simple boundary surface here. So this is my edge. This is my edge. I can custom preview. This is whatever that we have done before. That's why I'm just doing it very fast. This is just to show you the preview. Not so much for the logic. Okay. So you can see this now over here. If you want to hide that irritating point up, you can just don't show this. Right. So this is what we have created now. Okay. So you will notice that there are a lot more variations in the example files that we have here, right? You can even vary the heights of the panels. I don't need to go through that. What I just want to show you is, as of now, right? Okay, tying back to the earlier lesson last week, I can always rename this to be called my Esplanade. Did I call that Esplanade before? Oh no, yeah, this is default. Okay, so this is my Esplanade, right? And then I can always now select this guy, go and create user object. This is my Esplanade. My shortcut could be ESP. My icon can be it's hanging. No. Okay, my icon can be anything that I want to choose. Maybe I will just choose this purple thing. Right, and I click OK. So now I have this new command here. Okay, anytime I can just, as long as I have another surface, right, I can just anyhow create another surface here now. Okay, like this. I go back to my Grasshopper. Okay, this is my, I just set a surface. Connect this over here. I can put a slider, again 10 by 10. And remember to reparameterize. Okay, and now it will generate the same thing. Okay, I can just copy and paste this part also here. In fact, you can also do this boundary portions and the custom preview within Python itself. So you see, I can click on this to get this new Esplanade script. I can just double click and type ESP. That's my nickname for it, right? And it will come up over here. And you'll realize that this is whatever the previous guy, which we were showing in Ladybug or Butterfly for you. So for example, is this command here. Just randomly put one. Arrows. My computer is so slow. Okay, yeah. So this is the Ladybug command, right? He just created his own icon, which I've really shown you how to change the icon, right? And this whole thing is the same as whatever that you have done just now. So in the course of 2 weeks, right, you have briefly scratched the surface of what you can do with Python scripting first. So you can see here, this is where they create a function, which is the define. So the functions are all those like add polyline, vector create, okay, but you can even make your own things, which is what they are doing here. See, this concept for something in the range is what you have just learned. If is also what you have just learned. So you just need to get comfortable with what I have told you and taught you, share with you, and then you explore and experiment. That's all that they're asking for you. Just don't reject it. Because the more that you learn, slowly you will accumulate more and more comfort with it. And the more comfort with it, the more you can achieve. And the more you can achieve, the easier your life is. Right? Next time when you go out to work, then you need to, if you're an architect, then you need to do setback drawing, right? Just create your own script to do it. Then you can repeat the thing again and again. If you're a landscape architect, you want to plant trees very fast, just create your own script for it. It's all just using points and then setting up and drawing the lines and the curves. Okay? Or if you don't feel comfortable, at least next time you know that this exists. Then you can go and arrow some minion to do it. But at least you know that it exists. Then you don't keep thinking that you have to spend a lot of time to do repetitive stuff. Okay? So that is the end of today's lesson. I've also summarized for you what is the intent, right? The nitty-gritties, later you can ask your TAs respectively. The exercise should be quite simple from last week. So any questions as of now? I would just ask for all of you to go to the Good for Rhino website and download 2 plugins for the coming 2 weeks. Okay, the first one is called Caramba. Okay, Caramba is a structural calculation tool. Okay, I will put this inside the chatter. Oh, there's people asking questions. Oh, sorry. Okay, I will address this later. And then the other one is Opossum, which is written by my good friend, Professor Thomas Wortman, okay, who is in Stuttgart now. So he wrote this plugin in C#, I think, which is a progression from Python. Okay, so these 2 plugins, try to install by next week, but you will only use the first plugin first, the Caramba plugin. They will also be the last 2 exercises that you will do for this particular module. Okay, so technically by April the 10th, you will finish everything for this module. Okay. So if there are no questions, I'm just going to, so those in the LT can go to the tutorial portion. I will just talk to Add polyline for panel L. Okay, I will just show to Adeline where this part is the panel L. I do point. J plus 1. So here, yes, it's J plus 1. So it should be correct. So Adeline, can yours work now? I presume Samuel has already fixed it, right? Because that's earlier on. Okay, good. Thanks, Samuel. Then Adeline, yours okay? This is correct. Okay, hashtag panel. Maybe it's your comment that will. I don't think you need a apostrophe here. This one is not required. It should just read as this. So if you are okay, you can proceed to your TA portions, that TA values. and then I will stop the recording and upload it soon.